The first thing we did was set theory. So I've put up a few of the symbols up here. Some of the notation, intersection and union. And it gives some details there. Intersection, it belongs to both sets. Union, either or. We have proper subsets and regular subsets. A set that's contained in another set. A set that's contained in or equal to another set. Not a subset, not contained in the set. And then we have the element. So you do need to know this notation and how to apply it given different sets. Okay? And that's just when we get to set theory a little bit. Geometric terms. A point in an exact location in space or a flat surface. So your basic terms, so like the first question on your exam review was just a few of the terms. But if you look back in that first chapter, there's a ton of terms. So this isn't even all of them. All right, so you need to look back at your first test and your first chapter. And it just started introducing the geometry terms. Okay? And so as it introduces the geometry terms, you need to make sure that you know those terms and how to identify them in a picture. This gives a few examples. So not only do you need to know the terms, you also need to know how to identify them and how to do the notation. And so even on this last test, some of you, when you were ordering your line segments or when you were ordering your angles, you didn't put line segment or angle and you got counted off for that. So it's important that you pay attention to line segments, have the line above it, rays have the little arrow. You be able to identify a point or a ray or an opposite ray or a set of opposite rays. The difference between having the line above it and not having the line above it is whether you're talking about the actual segment itself or the length of the segment. So all of this notation that we've been using all along, you need to make sure that you understand how to use it and how to identify it given a picture. Same thing's true of three-dimensional pictures. Intersection of two lines is a point. Intersection of two planes is a line. The term collinear, we've gone over that. Coplanar. So you need to go back to that first chapter and look at those terms because there's a lot of terms, all right? And so if you go back to your test that you have, all the terms that were tested on the test, you're going to need to be able to identify or match or fill in the blank. We also did segment addition. Segment addition is when you add the two parts of the segment and you get the whole, which this is just an example of, but you actually did that on the first page. You'll also see segment addition. We also introduced types of angles here. Acute, right, obtuse, and straight angles. So you need to be able to identify the angle types. And then we also did angle addition, where the two smaller angles add up to the larger angle. And that's also on the second page there. Regular polygons. You need to be able to name your regular polygons by how many sides it has. We did two-dimensional figures like these. And then we also did three-dimensional figures. Remember with three-dimensional figures that you need to be able to name them by their base. So a pyramid needs to be more specific for me, all right? It needs to be what the pyramid base is. So whether it's a square or a rectangle or a hexagon, you're going to say a rectangular pyramid or a hexagonal pyramid. Same with prisms. Whatever the base is, this is a triangular prism. So whatever the base is, you need to name it by the base and the type of three-dimensional object there. Chapter 2 started our conditional statements and things like that. And we started out with just negations and conjunctions and disjunctions. So you'll need to know the notation there. And I think that's on into this. You'll see a compound statements. It says chapter 2 at the top. You need to know the notation for conjunctions and disjunctions. And you need to be able to apply it. So if it asks you to do a conjunction or a disjunction, or if it gives you the notation and asks whether it's true or false, you need to be able to do that. We also did conditional statements, if-then statements, conditional, converse, inverse, contrapositive, and biconditionals. All right? And so if it gives you a statement and it asks for the converse, inverse, contrapositive, you need to be able to write it and you need to be able to evaluate the truth of it. All right? You need to evaluate the truth of it. And remember, just from that negation, these little symbols means you're negating those statements as well. So whatever statements you've been given, you need to negate them in that order. We also introduced angles next. Special types of angles, vertical angles when two lines intersect. Remember that we have specialty angles here. We have alternate interior angles, right? We have alternate exterior angles. We have corresponding angles, all right? And so if these are parallel, which those indicate they are, you have special types of angles that are created, certain ones that are congruent, certain ones that add up to 180. Remember, your vertical, alternate exterior, and alternate interior are all congruent. Your consecutive interior, the ones on the same side, they add up to 180. They're supplementary. Okay, so you should be able to recognize those, name them, and then be able to calculate anything from it as well. We also did some formulas here: distance, midpoint, and slope. Your distance, subtract your two x's and square, subtract your two y's and square. Midpoint, you add them and divide. And then slope is the difference of your y over the difference of your x's. This chapter is also where we started doing linear equations. So where we started graphing linear equations, putting stuff in slope-intercept form. If you recall, slope-intercept form, y equals mx plus b, all right? Your m is your slope, your b is your y-intercept. So when you're graphing something like this, you start at your y-intercept on your y-axis. You go up or down, left or right based on your slope. All right, so this whole chapter dealt with that. We also dealt with parallel lines and perpendicular lines. Remember, parallel lines have the same slope. Perpendicular lines are negative reciprocals of each other. Negative reciprocals of each other. All right? And so you should be able to graph lines as well as find the equation of the lines given certain information. And you may have to use a combination. You may have to use your slope formula and then your slope-intercept formula to get that. Chapter 4 was all about triangles. The sum of the triangles all add up to 180. Exterior angles, so that two interior add up to your exterior angle. And so we introduced some just things about triangles in this chapter 4. We also did triangle proofs in this chapter. And so hopefully you recall your triangle proofs: side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse, leg. And so you will need to be able to recall that and recognize how to identify what you're using, which is in this review as well, and actually do your proofs as well. And for two-column proofs, if you'll remember that you have to do your statements, you're going to always start with your given. And this is true of the algebraic proofs, the segment proofs, and the triangle proofs. So we've really done 3 different types of proofs this year. We've done just basic algebraic, where you're given an algebraic solve for x and give me the steps as how you did it. Or we did line segments, where it's a midpoint or things are congruent and you're trying to prove other things congruent. And then where we did triangles and congruence with triangles. And so you'll always want to start with your given. Your middle steps help you to support your conclusion. You're always going to end with whatever you're trying to prove. And so you will have some two-column proofs on this as well. The most recent thing we did, chapter 5, were our centers of our triangle: circumcenter, incenter, centroid, and orthocenter. You need to know what makes it up, and you need to know all your calculations based on that. All right? And so the first 2 actually have some specialty as well. Your circumcenter is the same distance from your vertices, and your incenter is the same distance from all your sides. And so you want to know what makes them up and how to then calculate based on knowing what you have.